Socratic Math Tutor here. So today we're going to learn how to recover the rule for a function just from a graph and some points on that graph. So let's have a look at an example. Assume we're given some axes like this. I'll put x here and y here. And let's assume we're given something that kind of looks like cosine. We're not quite sure what it is or what the equation of this is, but we're given some points on it. So this local maximum is going to be pi over 6, 7. And this local minimum will be 7 pi over 6, negative 3. And we're told to find a relation between y and x. And the hint is find it in terms of cosine. So this is some kind of dilated and translated version of cosine. And our goal is to find it. So to get started, what we're going to do is we're actually going to graph cosine over here. We'll call this x dash and y dash. And we're going to graph y dash equals cosine of x dash. And we're going to try and graph enough of it that it kind of looks like this, but just not dilated and not translated. So we'll start at 1. This is the point 0, 1. And then we fluctuate down. This is what cosine looks like. It comes back up, and it just waves like that. We'll mark this point with its coordinates. We know it's at height -1. And to find the x dash value, there's a few different approaches. My preferred approach is to just keep in mind that important points on the cosine graph are separated by pi on 2. So these 2 points are separated by pi on 2. These 2 points are separated by pi on 2. Same with these 2. Same with these 2. Same with these 2. And same with these 2. So now we just count. So 1, 2, 3, 4, 5, 6. And each of these has a gap size of pi on 2. So this number should be 6 times pi on 2, which is just 3 pi. So that's kind of how we set up the problem. And now the idea is that we want to transform this graph to get this graph. And so in particular, this point here with coordinates 0, 1 needs to map over to this point with coordinates pi over 6, 7. And in a similar way, this point here with coordinates 3 pi, -1 needs to map over to this point with coordinates 7 pi over 6, -3. So this is going to go there, and this needs to go there. And we need to find a transformation that does that. So that's really the problem here. Okay, so to actually find such a transformation, what we need to do is start off by working out how much it's stretching or shrinking in each direction. So for example, in the x direction, well, we've got a pair of points here with 2 different x values, like that. And these are getting mapped to these points, which again have their own x values. And so if we look at the difference in these x values and compare with the difference in these x values, we're going to be able to work out how much this transformation will either stretch or shrink things in the x direction. Okay, so let's work out this length. We do that by computing this difference. So delta x dash equals 3 pi minus 0, which is 3 pi. And to find out this distance, we'll compute this difference. So delta x equals 7 pi on 6 minus pi on 6, which is pi. And so as you can see, the scale factor here has to be 1/3 because we're kind of contracting this distance down by a factor of 3 in order to get this distance. And so what that tells us is that this variable x has to be a contracted version of x dash, so we can write x equals x dash over 3, and there'll also potentially be a translation in the x direction, so we'll just put a capital A here to account for that. We don't know what capital A is. Okay, in a similar way, we can compute these differences right here. So delta y dash is going to be -1 minus 1, which is -2. Delta y is going to be -3 minus 7, which will be -10. And so obviously we need a scale factor of 5 to get us from -2 to -10. So y equals 5y dash plus potentially a translation. So just to recap, we did this difference divided by this difference, and that gave us the scale factor in the y direction, which was 5. And we also did this difference divided by this difference, and that gave us our scale factor in the x direction, namely 1 over 3. And now it's just a matter of finding these constants. So the next step is pretty straightforward. I am actually just going to move things over a bit to emphasize the comparison between this part and this part. So let's go ahead and find capital A. Let's do this part. What we do is we choose a row here, so either this row or this row. I'm going to choose the top row because basically the numbers are just easier, and in particular this 0 is very convenient. So what this is saying is that 0, 1 is supposed to map to pi on 6, 7. So in particular, if x dash equals 0, then x should be pi over 6. So we can put that in here, just like that, and it becomes clear that A equals pi on 6. So finding B is obviously very similar. Again, we can choose either row. I'll use the same row here. Once again, because 1 is just a bit simpler than -1. So we know 1 needs to turn into 7. So I'll put 7 here. 7 equals 5 times 1 plus B. And therefore, we conclude that B must be 2. And therefore, we've solved this problem. We know that x has to be x dash over 3 plus pi on 6. And that y has to be 5y dash plus 2. Okay, so we found a transformation with the desired properties. Here it is. Let's get rid of all this stuff and just keep the transformation. Okay, so at this point we're nearly done. The only problem is the equation we've got says y dash equals cos of x dash. And the problem is that x dash is not the subject of this equation, and y dash is not the subject of this equation. So we can't actually plug these directly into here. First, we have to rearrange. So if we rearrange this equation, we get x minus pi on 6 multiplied by 3 equals x dash. And similarly, we can rearrange this. We'll get y minus 2 over 5 is y dash. And so now we can put these formulae into this equation. So y dash equals cos of x dash becomes y minus 2 over 5 equals cos of 3 times x minus pi over 6. And this equation is the one we were looking for. So if we want, we can write that up here. And that should get you full marks for this question. Now, of course, if there's a specific form they want this in, you might have to rearrange this equation a bit, but those details depend on the specific phrasing of the question, so I'll leave that kind of stuff to you. The important thing is really to get this equation, and then whatever changes you need to make to it to get it into the desired form, you'll be able to make using simple algebra. So that's it from me for today, but be sure to tune in for the next video. We're going to look at harder versions of essentially this same family of problems. Sometimes the dilation factors just aren't that easy to work out. They don't fall out as easily as in this problem. And so we're going to take a look at what to do in those situations in the next video.